Assalamualaikum dan selamat sejahtera. Now I want to show you the last subtopic 7.3 solubility equilibria, just to focus in common ion effect. Alright, okay, we just refer to the question of tutorial, question number 9. Calculate the solubility of silver chromate Ag2CrO4 at 25 degrees in pure water and in solution 0.005 molar potassium chromate. Then explain the difference in the values of solubility. Okay, first of all, you have to know, when you read all the question, you have to know what's the slightly soluble ionic compound that involved in this question. Okay, that means what is your salt in your question. Okay, now the question is, the silver chromate in this question is referred to your salt, right? Okay, for A, imagine you have Ag2CrO4. You want to calculate the solubility dissolved into the pure water. If you want to find the solubility in pure water, just refer to how to calculate solubility based on the previous lesson. Okay, how you want to calculate solubility? That I said before, if you want to calculate the solubility, you needed ice table. Alright, so for question number A, if you want to do the ice table, you have to starting with the equation. What the equation involved for this? You must dissociate your salt here, right? Ag2CrO4, okay, slightly soluble to produce its ion. Okay, if you don't know the charge, you just refer to this. That means 2 is for 2 minus. This is 1, that means positive 1 for your cation. Then you have to balance. Since Ag2, here you must put 2 here. Then as usual, you do the ice table. Okay, the unit is in molar. Okay, your solid not involved in this question, right? At initial, the molarity for your ions, okay, both is 0 because this not produced yet, right? As usual, positive, that means increase the molarity of its ion. How many increase? 2 times. That's why you put 2s here and 1s here for chromate, right? S stand for solubility. That's why I write S. Okay, next, your equilibrium, as usual, 0 plus 2s will become 2s, 0 plus s will become s. Right. After you do the S table, you have to write the KSP expression. Concentration product, your silver ion, power is Tokyo multiplied by another product, power is Tokyo. Right, and then you just substitute the value of each ion and KSP. KSP for silver chromate here is 9.0 exponent negative 12. Ag refer to the row equilibrium to S, since it's power of its 2, so square here and S. Then you settle down, will become 4s cubed because 2 power of 2, right? 9.0 exponent negative 2 and you get the S value is 1.31 exponent negative 12. Sorry, negative 4. Okay, so you must write the conclusion. So solubility silver chromate in pure water goes to 1.31 exponent negative 4 molar. So if you want to find the solubility, the salt in pure water, any salt, okay, you just write the as usual. You just solve as usual. Okay, needed ice table, and then KSP expression, and then find the value of S. Then you conclude. 4 steps here. 1, 2, 3, 4. Okay, now we want to calculate the solubility of silver chromate in solution of 0.05 molar potassium chromate solution. Okay, that means, okay, for B here, you want to calculate the solubility of your salt, which is silver chromate, in, right, now in potassium chromate. The molarity here is 0.0005 molar. So for this case, if we want to calculate the solubility of silver chromate here, you have to determine either the common ion is present or not. Because common ion, okay, the presence of common ion will reduce the solubility of the salt. Alright, this is your salt. So sekarang you kena detect macam mana nak tahu dia ada common ion ke tidak. Okay, you tengok pada cation ataupun anion. When I say common ion, that means ion sepunya, ion yang sama, right? Tak kisah sama ada untuk cation ataupun anion. For this case, you nampak Ag. So dalam solution ini ada tak Ag? Tak ada. So that means Ag is not common ion, right? How about chromate here? Yes, you nampak sini ada CrO4. Di sini also ada CrO4. So that means CrO4 here, bila salt ini ada CrO4, your solution also ada CrO4. That means dia ada common ion. For this case, your common ion adalah yang sama itu dinamakan CrO4 2-. First thing you have to know, what is your common ion for this case? Alright? So since you dah tahu common ion adalah CrO4 2-, that means you still nak cari solubility. Solubility ice table needed. Right? So when dia ada common ion, bermaksud pada row inertial bukan lagi nilai 0 untuk CrO4. Okay, untuk CrO4 saja, sebab CrO4 adalah common ion. So pada row I, nilainya adalah sama dengan concentration solution di dalam beaker. In beaker. Okay, berapa concentration dalam beaker ini? 0.05. That means concentration initial pada CrO4 juga adalah 0.05. So now I want to do the ice table. I start with the dissociation your salt. Okay, as usual bila kita buat ice table, kita kena ada equation. Equation ini adalah dissociation salt. Jangan salah. Alright, dissociation salt. So di sini your salt adalah yang saya bulatkan ini. Ini adalah solution solvent dia. Alright. So Ag2 CrO4 solid. Okay, slightly soluble, become its ion. Right. Okay, then you balance the equation to here. As usual, inertial, change, and equilibrium. Unit molarity. Solid not include. Alright. Inertial for Ag is 0 because Ag for this case not common ion. CrO4 is common ion. So it will produce the common ion effect, kesan ion sepunya. So kalau ini common ion, that means value for inertial bukan lagi 0, but nilainya adalah concentration solution ataupun solvent kita panggil. So for this case, solvent kamu adalah K2CR4 molarity 0.05. So di sini pun nilainya adalah 0.0005. Kenapa? Sebelum garam ini dimasukkan di dalam this beaker, nilai CR4 sudah ada di dalam solution tersebut. Okay, so kalau you tambah lagi nilai, okay, dia telah meningkatkan concentration yang ini, CR4 2 minus. So kalau dia meningkatkan lagi concentration CrO4 2 minus, dia ada kesan yang lain. Right, later I will show you what's dia punya effect. Right, so as usual, product is increase the concentration. How many? 2 times, so we become 2S here. Okay, now here saya takkan guna S. Normally kita akan guna S, but since dia adalah solubility in common ion, okay, solubility in common ion, alright, so saya takkan guna anon S, saya akan guna anon lain. Contoh saya akan guna adalah Y here. Kalau impure water ataupun solubility yang biasa kita cari, kita akan guna S. Since di sini ada wujudnya common ion, saya akan guna anon Y here, nak tunjukkan perbezaan nilai solubility. Okay, tak ada apa-apa masuk pun. Right, nak tunjukkan perbezaan sahaja tentang solubility. Right, so 0 plus 2y will become 2y here, and here becomes 0.0005 plus y. Okay, right. After you do the ice table, as usual, you akan write KSP expression. Okay, and then here kamu akan masukkan nilai, right? 9.0 eksponen negatif 12 equals to, ini refer pada row equilibrium, 2y square. Di sini kita akan masukkan row equilibrium, iaitu 0.005 plus y. Okay, after you insert the value for each species, you have to write assumption. Assume y is very small. So kalau nilai y ini terlalu kecil, dia tak memberi efek pun kepada nilai 0.05. Thus 0.005 plus y tidak memberi kesan approximately nilai itu kekal menjadi 0.005. Contoh kalau y ini adalah 1 eksponen negatif 5, 0.00001. So kalau you tambah dengan 0.05, masih nilai dia 0.005 juga. That's why saya assume di sini approximately nilai dia masih sama. So you abaikanlah nilai ini kalau dia terlalu kecil. We akan negligible the value of y here. Okay, masa bila saya nak assume yang ni, bila nilai KSP yang diberi, okay, nilai KSP yang diberi untuk salt ini adalah starting daripada negatif 5 dan ke atas. Contoh negatif 5, negatif 6, negatif 7, negatif 8 and so on. So lagi besar nilai dia 5, 6, 7, 8, you akan terus assume di sini. Okay. Dan normally KSP yang akan diberi adalah memang nilainya adalah besar, negatif yang terlalu kecil, nilai terlalu kecil. Okay, negatif 13, negatif 10, negatif 9. Okay, kenapa kita ambil nilai yang kecil? Sebab kita fokus kepada salt yang slightly soluble sahaja. Okay, so based on my previous video, I already told you that the slightly soluble ionic compound will have the smaller volume, the smaller value of KSP. Okay, compared to 100% soluble ionic compound. Right? So after you assume here, you rewrite again the value, but this time without the term Y. 0.005 only, without the term Y here. You must rewrite again. Then you settle down, okay, the value of Y. Okay, macam biasa tekan calculator and you get here 2.12 exponent negative 5. So conclusion, solubility Ag2CrO4 in 0.005 molar K2CrO4 is 2.12 exponent negative 5 molar. Okay, this is the step that you must do. First, istable as usual, KSP expression, then insert the value, assume, rewrite again, and your conclusion. This is your 6 step that you must include in your calculation. Okay, now we want to explain the difference, right? Difference value of solubility. So di sini ditanya apakah berdasarkan solubility yang kita dapat daripada part A and part B, cuba kita terangkan kenapa adanya perbezaan antara these two solubility. Okay, for part A, kita cari solubility silver chromate dalam H2O, we get 1.3 exponent negatif 4. But kalau untuk part B, kita cari silver chromate solubility dalam potassium chromate, kita akan dapat 2.12 exponent negatif 5. So berdasarkan nilai ini, kita nampak nilai solubility di dalam potassium chromate adalah lebih kecil sebab negatif 5 di sini. Ini negatif 4. So, ayat yang pertama you kena nyatakan adalah solubility. Alright. Silver chromate in potassium chromate is lower than in pure water. Okay. Ini ayat yang pertama you nyatakan siapa tinggi, siapa rendah. Alright. Okay. Yang kedua, you kena terangkan kenapa you said lower. Because in K2CR4 it exists the common ion which is CrO4 2-. So yang kedua, bila ini lower, bermaksud satu saja faktornya kalau dia lower solubility, iaitu wujudnya ataupun the presence of common ion. Okay, ataupun presence of common ion. Okay. Okay, selepas you nyatakan ada presence of common ion, nyatakan apakah common ion tersebut, Ag ke CrO4. Okay, berdasarkan garam ini common ion Ag ke ataupun CrO4. Right? So yang saya nyatakan di sini ada koma ion iaitu CrO4 2-. Alright? So it will increase the concentration of CrO4 2- here. Okay, sebab berdasarkan dissociation CrO4, okay, saya tunjuk okay, bila mana CrO4 ini sebagai common ion, bermaksud ion itulah akan ditinggikan concentration. Okay, for this case CrO4 yang common ion, bermaksud concentration ini yang tinggi. Okay. Bila concentration CrO4 2- tinggi, bermaksud site sini okay, akan terganggu. Berdasarkan Le Chatelier principle, bila sesuatu keadaan terganggu, disturbance, sistem akan counteract. Okay, and then the action dia akan shift ke kiri ataupun ke kanan untuk reducekan dia punya disturbance tersebut. Betul? So di sini bila mana concentration CrO4 meningkat, sistem akan counteract untuk reducekan balik concentration CrO4. Bila sistem nak reducekan concentration ini, sistem akan shift to the left. Bila shift to the left, automatically concentration CrO4 2- akan reduce. Alright, so teruskan. Will make the system shift to the left. Alright, bila dia shift to the left, bermaksud dia akan form silver chromate dengan banyak. Okey, kita tahu bila dia form silver chromate dengan banyak, silver chromate adalah dalam bentuk solid. Bermaksud dia akan membentuk banyak solid di dalam beaker tersebut. Okey, dalam solution tersebut. Thus, bila dia membentuk solid silver chromate dengan banyak, okey, so it will increase the formation of silver chromate. Alright, bila bentuk banyak solid, solubility bertambah ke berkurang? Kita kata kalau sesuatu solution lebih soluble, bermaksud solid dah makin kurang. Sekarang solid semakin banyak. Ini membuktikan the solubility is reduced. Thus, the solubility Ag2CrO4 in K2CrO4 is reduced. Okay, inilah explanation untuk terangkan kenapa berbezanya nilai solubility in water and potassium chromate.